Okay, hello everybody. Oh, I got more people. All right. Okay, we're going to get started today because we got some big topics here um, to do. So, welcome everybody to Origins After Class webinar series. This one's for obviously for December, and today we're going to be discussing giving an introduction to evaluating component assemblies using CheckMate SoftFit. And today we have a special guest presenter, Rob Johnston from CAD Micro Solutions. And just going to give you just a quick little heads up, and then I'm going to give it over to Rob, and he can give you some information. But Rob's been doing some really cool projects with CheckMate for the last few months. And we've asked him to present some of those, I'm going to say, application workflows today. One of those applications includes the analysis of multiple parts in an assembly. So today we're going to start, this is an introduction to get you guys kind of warmed up to this. So the example that we're using today is just going to be two components fitting together, just so you kind of get the gist of it. We're going to be having more webinars early in 2023, and we're going to take this kind of to the next level, because how many people just have two components that have to fit together? You know, we're going to be dealing with more components in the future, multiple components, and putting them all together and seeing what we've got going. So, but I'm going to let Rob go in and take over from here. So, Rob, if you want to just start sharing.
Sure. Thank you, Cecil. Can you hear me okay?
I can hear you just fine, Rob.
Okay. So yeah, I'll share my screen. Just let me know when you can see it okay.
Looks good.
Okay. Thanks everyone for joining. Cecil and the staff at Origin, thank you for inviting me today. As you mentioned, Cecil, I spent a lot of time in the last 3 to 6 to 12 months doing what I call assembly analysis and stack up analysis with CheckMate. And in our discussions, you asked if I could put together a quick presentation of the tools used inside of CheckMate to go and do this. So I'm not going to go through any big sales presentation or anything like that. We're going to just spend 2 or 3 minutes on a slide deck to set up the story and the challenges that a lot of the customers that we've been dealing with in the last 12 months have been facing. And then some of the tools that have been in some of them that have been in CheckMate for a long time, but others that have been recently added or updated are also going to be shown. And I like to think of it as putting a bunch of puzzle pieces together to get to that common solution or common task at the end. So again, thanks for inviting me to speak today. And I guess this video will be available for anyone that wasn't able to attend, et cetera, et cetera. So, again, I work for CAD Micro Solutions. We're a Canadian company. We have 5 offices across Canada. I typically am in the Toronto or Cambridge office, but there's about 70 people, and we do a bunch of different things. We're a SolidWorks partner. We do a bunch of additive manufacturing, and then obviously the metrology group that I head up as well. I'll just quickly skip through this. This isn't important. And my group, all we deal with is scan data, which, the manufacturing world is still kind of transitioning. There's a lot of industry segments where scanning has standardized. There's others that are still heavily using CMMs, and there's a lot of people in the middle. So at CAD Micro, we deal with handheld scanners and area scanners on the reverse engineering side, and we deal with GOM, which has now been bought by Zeiss, on the metrology class scanning. And there's a big difference in that I'll talk about in a second. But sometimes, and this is an example of using CheckMate for SolidWorks, a plugin inside of SolidWorks with that metrology grade scan data. And for those of you coming from the CMM community, I'm going to put up some flags and definitely let you know that this is not just dependent on scan data. You can do this assembly analysis or stack up stuff with your CMM data as well. You're just going to be limited to where you've measured. And I'll definitely put up those flags. So the first kind of little indicator or warning is that while I used scan data to get to the end in some of my conclusions, there is nothing that is directly correlating that you have to have that. It can come from whether you programmed your CMM with CheckMate, whether you've imported your CMM program into CheckMate, whether you've imported your results from your CMM into CheckMate. There are lots of different data entry points. And once you get to what we call the reporting entity level, and that relationship between the two parts, it's not just dependent on scan data. So real quick, applications of scan data, you can use it to tell if you've got one part that's good or bad. You can use it, as we're going to show you today, for dimensional assembly analytics or reverse engineering or surface defect detection. And those are the four things that we do 99% of the time with CAD Micro, is kind of helping people and selling solutions into these kind of spaces. We always say the word metrology grade scan data, which is where you're starting to get into your point spacing down into microns and measuring down to about 20 microns in a accuracy or repeatability point of view. So you're getting down there. I mean, today's technology is not ever going to replace CMMs on 5 micron stuff, but it's getting better all the time. And it's one of the real value statements of GOM and Zeiss and their scanners is the quality of the mesh that it produces to allow us to do dimensional analytics, as you're going to see today. I always like to put up this as a reference, and it may be fair or unfair, but when we look at mesh comparisons, whether it be for reverse engineering or for quality control or dimensional analytics, it's what data do you want to be working with? And it's a very simple visual indicator of, low grade scan data versus metrology grade scan data. If you've never seen a scanner work, it's a simple, in the GOM world, there are handheld scanners, there are robot-based scanners, CMM-based scanners. This is just a very simple visual of what we did to go out and collect data on our part. This isn't the part we're using in the presentation, but just a very simple example. And so today's presentation of using CheckMate for SolidWorks and using the SoftFit tools for assembly analysis, it comes down to two questions: is will they fit, or why aren't they fitting? And that's a really important designation. It's just language that we learn as we go through more and more of these projects. Is if you've got the two parts in front of you, just see if they fit together. But there are lots of scenarios where they don't fit together and you're trying to figure out why, or you've got CMM data from supplier A and scan data from supplier B, and you want to be able to, the two parts have never been in the same room together. And while each quality department is laser focused on getting their part, off of their quality control device and making sure it's a good part, and then making 10,000 more of them, it's typically often very individually focused. And what this is about is putting two of those scenarios together. So what, each of these parts have their own world. They have their own drawings. They have their own dimensional requirements, their own datum structures, their own MBD, PMI information. This was a part that we used that came from SolidWorks. It had the luxury of having model-based definitions, and it doesn't mean you have to have that. If you don't have that, it means you have to program it manually or load your CMM program. Like, you just have to have this relationship of, here's your CAD data, what do you want inspected on it? What defines the mating components? What defines the critical features? We then go scan the data and we put them together. So this is just a cross-section of them. But, and we're going to conclude right at the beginning, these parts do not fit together, and it's one of the things you want to find out as early as you can is, well, why don't they, they're not neither one of them are really truly dimensionally accurate. And of course, in a massive volume production, it would never get to this point. But when we're in pre-production, when we're R&Ding or sending parts around between suppliers, learning to build things, we want to see how things are going to fit, and if they're not, create actionable results on why aren't they going together. Yet actually never measuring it as an assembly. And I think that's an important differentiator. We are measuring two parts independently. We are analyzing them together. We did not scan these once they were assembled together and see where they're at. So a couple of different terms that we're going to be throwing around. So as Cecil said,
Rob, can I
yep.
just quickly? So these two components then could have been made from two separate suppliers, right? They might have inspected the parts themselves, said, hey, our parts are good, right? Here's the data, right? But then suddenly when you get to the assembly location or company or factory or whatever, suddenly there's a fit and finish issue. There's problems. So is this the kind of thing you'd be looking to fix?
Yeah, it's one of the things that we've fixed for one of our clients where both parts were dimensionally accurate and to the drawing, but they wouldn't go together. This is just an example of that workflow. It's not on these two parts, but awesome. The two parts had never been in the same building, and they'd realized they were missing callouts, and actually one of the tolerances on a couple of the features were wrong, and they were able to. It was a red flag a lot earlier in the process. Is what it really led to at the end of the day.
Oh, okay. Well, thanks for clearing that up. Thank you very much.
So as you mentioned, this is kind of demo 1 or webinar number 1, where we're just going to highlight what I've done. But I've been talking to you guys that we can only get so far in kind of a half an hour or 30-minute window. And we brainstorm ideas to do another webinar maybe in February to do the second half of the equation, which is what I call stacking fits, where in the customer example, we actually had two parts that made it together. Then those two parts actually become a new part. And we stack those results to be analyzed on a third part. So it doesn't get more complicated. You just have to be more organized. But we're going to plan to do that with some of the new tools coming in CheckMate 2023 as well. So today is just an introduction to tools, introduction to workflow, stacking two parts together. How some basic organization tools, some reporting options, and a sneak peek of a tool that's coming down the road. I wrote this just as a basic introduction that everybody should be familiar with this workflow, where we write a CMM program, we run it, we collect the results, print the report, analyze the part, and then try and figure out what's wrong. And that's kind of been the standard workflow for a long time. And when you're in assembly analysis, we've realized that it's a little bit different. There are some repetitive things in here, but this has kind of been the left to right workflow. In order to do this left to right workflow on assembly, we have to introduce some new tools. And the first thing we have to talk about is merging nominal databases. It sounds like a big fancy term, but it's really not. That you may have, in the example, a slide I showed earlier, you may have one MBD definition on part A. You may have an MBD definition on part B, but how do you put them together, especially if there's A, B, and C, or D and F in both files? Or I have MBD on one part and a CMM program on another part. You have to have a mechanism to merge these nominal databases together. And that's what I call puzzle piece number 1. And we'll definitely do a live presentation on that. Puzzle piece number 2 is being able to load data, but just have it analyzed to its respective part. If you've got multiple parts loaded in a file, you have to make sure from an organization point of view that say that scan data can only be analyzed to that part. So there are some really neat tools that, again, have been around a long time to allow us to turn accessibility on and off. Then there's reusing some very old tools, what's called creating alignment fits per part, where I want to create an alignment on part 1 ABC and align it to part 2 DEF. Not all ABCs align with each other from a feature control frame point of view. So there's a pretty neat set of tools to do that. Again, just been around for a long time, using them in a different way. And lastly is loading the actual STL files for visualization purposes. You don't really have to do this, but when you're trying to figure out what's wrong or why they're not fitting, it's a really valuable tool for coloring things, for assessing if parts are going to fit together. Again, whether you're trying to figure out why they don't or before they're even in the same building. And together, if we put all that together, we've used these tools to help one particular client out in mating parts that had never been in the same building. And then in early November, they finally did come in and they did all 30 parts and everything worked flawlessly. So it was a really cool experience on, they had one additive manufacturing part and one plastic injection molded part. I obviously can't show that for NDA reasons, but we came up with this to kind of share the workflow because it worked really well. Okay, that's it. That's all I have from a slide deck point of view. I was going to go into the software now. Are there any questions or comments at this point? Okay, I'll keep going then. Here I am in SolidWorks 2022. For anybody that's a CheckMate user out there, I just wanted to show that there's nothing been predefined. There's no levels, no programs, no nothing. So it's not like, hey, there's a bunch of hidden shit that's been gone on in the background. Oops, sorry about that. There's not a bunch of stuff that's already been predefined. And I have two parts. So we took these two parts and went into basic assembly. I'm not a SolidWorks expert, but we went into SolidWorks assembly, mated the two parts how they were functionally supposed to be aligned, and then just saved that as a PRT file. There are some things we can do at the assembly level. For this round, we just kept it at the PRT level to keep it clean and simple to kind of explain. So the first kind of step in that process was loading data from different nominal sources. So I'm just sitting here in CheckMate. I could go and write my program if I wanted to right now. I'm going to just hide the pink part. And what we're going to do is, as I said earlier, is there's a really cool tool that allows you to go into that part file, do an auto MBD or write a program manually on just the black part and save that out as a file called just an export file. And we have the ability to move these files back and forth from part state to assembly state kind of easily, and it's really nice. For anybody who hasn't seen CheckMate before, these little yellow tick marks that are all over the part just represent everywhere that the call outs, in this case on the MBD level, ask you go and take measurements. You can see here in the programming browser how it's just automatically pulled in all of the features, all of the tolerances. You've got datums A, B, and C. You got datums D, E, and F, some profiles, and just your standard kind of metrology stuff. One of the big things that you have to do when you're doing assembly analysis is you have to really know how to control things visibly and keep the screen organized. So what I just did there was, again, load the MBD extracted program from the individual part file, and I'm moving this into a separate project for the assembly analysis. So it's just kind of keeping things organized. And at that point, we'd simply say, hey, well, I've got my nominal definitions. I've got what was asked for to be analyzed on the part. So go ahead and load in the actual scan file. Some of you may or may not have seen this before, but I just have one for each part right now. And I just go ahead and say, go ahead and load the data. And again, it wasn't, there wasn't anything really tricky here. Let me just go back one step. Has anybody seen that kind of scan data stuff before? Like been seeing these kind of plots or anything?
You mean like the color map that just got created?
Yeah. I
It's
guess
hard
that's
to
I
say,
do
Rob,
that.
because we get a big mixture
okay.
of people with CMMs and with scanners. So
Okay.
This is Jim. I've seen it with Polyworks. Very similar.
Yeah, that's right, Jim. It's similar. It's just pulling in data from a different source and applying the color map. The other
Right.
thing, I'm going to go back and do that again. I just wanted to show you something else that I think is pretty neat on this nominal side. I just got to go back and do that quickly for a sec. Oh, there you go, Cecil. For the
yeah,
first time
that always happens when you
in a
got a
in a
bunch of people watching.
in a demo, I deviated from my to-do list. So I was just going to show what's called uh, verification spheres. So I'm going to just quickly go back and just start that again, all the way back from plane. It won't take me long to get back there. Just go back this far. There we go. Bring back the middle part. Okay. So pretty easy. It's a good little indicator of the process. Okay, so that's as far as we got before, and what we're going to do now is just load the scan data. Okay, so here's the scan data, and Jim, that's kind of what you were saying before. You've got a color map on top of the part, so very similar to what you said about Polyworks. There are lots of softwares that do that, GOM Inspect and what have you. It's just real nice to do this right inside of SolidWorks. And kind of the next step, that's a bit of a weird step, is we're going to just do something very similar to what the CMM people are used to. Is we're going to say process the color map against the program. So I go ahead and hit just choose the option, all the defaults and what have you. And it goes through and it creates reporting entities for all of the places the program asked for things to be calculated. So again, just from a visibility control point of view, I don't need to see those little ticks. But again, we've got a color map. There's all things you can do about changing colors and all that stuff. What I'm going to do that's a little bit different now that some of you probably haven't seen before is I need to create an alignment. Right now, this is just best fit data. Sure, everybody's heard that word before. And I go and say create an alignment. And you'll notice that there are two things already pre-populated. These are pre-populated from the MBD file that was import or automatically produced on the file. So it knew that there were alignments in there for both A, B, and C and D, E, and F. So there must have been some true positions in here. There must have been whatever. And I now have two alignments. And what it allows me to do is actually just cycle between the two alignments, and it updates the color map. But again, this is kind of still just at the component level, and I can see, I can always go and change the tolerance if I want. I don't know. This was just a demo file. So if I just go apply, it's just looking and learning to manage your color maps. So what part is good on the part, what part is bad. And a lot of people, this is good enough to create actionable data. That's just a question of, is it good enough? So it's kind of cool. It's kind of neat.
From the component level, though, right?
From the component level. This is just
looking at this part.
It's got nothing to do with the fact that the pink part sitting there in the background. We'd only scanned this black part. Okay. And kind of what we have to do next is kind of a little bit of work for where we want to be downstream, which is we want to load in the actual scan file. So the first thing CheckMate did was it loaded the STL file and automatically aligned it and automatically produced colors. And it did a little bit too many things for me. I want to go back and just do something manual because I need the mesh data downstream. And I'm going to just load that in kind of as a file all by itself. And you'll notice you kind of get this gray blob out in space. That's what the scanner actually scanned. And I'm going to go in and it's just going to do a little bit of strange operations if you haven't done this before. And that's it's called applying a transformation. And I'm going to say, take the hot data or whatever I made red, and I want you to take the transform from the way it was loaded and go and apply it onto the part. And what you'll notice is the red went down. Now that's just best fit. That's not what I want. I want the scan data aligned to the actual D, E, and F. And now I'll explain that. So A, B, and C on this part were kind of like the bottom, this pin, and this face here, like your standard 3-2-1 alignment. But D, E, and F were defined as this axis of this hole, this upper hole, this plane, and then the clocking based on this keyway. So what I need to do is go and update the color or the mesh, the STL file, to be in the exact location relative to the DEF alignment. So I just have to do that one more time.
So that, Rob, the DEF is
Yep.
is that like similar to what the A, B, and C would be of the mating part, the pink part?
That is correct. Yep. So when
okay.
Exactly right, Cecil. So when on the pink part, the ABC of the pink part actually align functionally to the DEF of this part.
Cool.
Now I'm going to do one last thing on this, and this is only for visualization downstream. And that is, I'm going to change the color of the mesh from gray to black. So if I kind of come in here, it's just something that I like to do, change the color of the hot data, hit it to be black, now do hot minus all. And it's now just black. So in all these operations that we've been doing, there's a bunch of what we call levels that get created, or layers. Just going to turn that off. I don't need to see that again. It's now been loaded. It's aligned. Everything's ready to go. So now we got to kind of repeat the exact same thing on the pink part. So it's the same process. So if I wasn't yapping along here, I could do this. I did the whole thing start to finish in about 8 minutes. So what I'm going to do is, I don't need the color map for the blue part anymore. Sure, we can kind of see that blue is telling us that it's a little bit shallow, meaning there's less material there's not as much material as there should be. So we already know it's by the color map, it's already a little bit undersized, but in these areas, that's probably a good thing. I actually don't need that color map, so I'm actually going to delete it because we're going to have a second one on the other part. So let's just go do our SolidWorks magic. I'm going to hide the black, unhide the pink. And again, this is just the way I organized it visually to kind of get these messages across. And we're going to go and repeat the same exercise. And now we get to kind of show you some other neat things about CheckMate. So I'm going to go and import the same file for the pink part. It had an MBD data structure. It had its own SolidWorks file. We did an auto MBD. We saved that out to what's called an export file. And now I'm just going to go and import that file. So I'll go ahead and import. And one of the things you'll notice, two things happen, is that you actually get a new folder called black part, pink part. So it just imported all that. But something very cool happened. It recognized that, let me expand this. It recognized that there was an A in a previous folder. So it put a P here kind of as a prefix because you don't want duplicate labels. So it automatically renamed these.
Was that P for pink?
No, I wish. P for prefix.
Oh, prefix. Right? Okay, sorry.
Yeah, and it just means that, and you can control that prefixing as you want. I just did it for now. I left it at P for prefix because you can't have A, B, and C for this and A, B, and C because there is an A, B, and C on the black part, and you have to be able to manage it. So there's some things been done under the hood to do that for you automatically, rather than go back to your program, your MBD program, rename things, re-output it, re-export it. It kind of does all this. So here's the kicker if you've never done this before. If you've seen CheckMate segments, you'll see that there are green dots here. We didn't have to do this the first time because I was only loading one file. Now that I already have one loaded, I got to be a little bit smarter with my management. I have a blank program here, so I guess I could do that too. I'm going to now load the second color map. So load the color map, load the STL file and do the color map evaluation on the pink part. And again, pretty easy. It's just your basic color map stuff. And you could sit here and play with this for hours if you wanted. But the reality is, where the trick is using these on and off switches properly. Because now when I actually say import results file, and store it in the pink folder, blah, 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 just my standard defaults, even it only analyzes what's in that segment or what's in that part. And that's a huge, huge plus, because now I have two actual groups in here, one set of results for the black part, another set of results for the pink part. So I know I'm explaining a lot, and you can imagine if I wasn't talking, this goes fairly quickly. But I've got another set of results, which allows me to do that other thing I did before and say, I want to create an alignment fit. And look at that. It knew that there was an ABC from the pink part as well. So yeah, I want to go and create an alignment out of my ABC features. And what you instantly see is that, well, on the side of the part with all the datums and stuff, it went a lot greener than the other side of the part. So what you can see in this little demo training file, you can see the part's undersized and it wasn't printed very well. But again, that's just dependent on your tolerances and what you're looking at. But essentially what we've done is we've loaded two parts. We've loaded them scanned independently, loaded them on top, aligned them to themselves. So if they're both in the, again, I can bring back my black part to illustrate the point. It's as if it was sitting in assembly condition. So pretty basic, pretty easy to understand. And I'll just turn that off again for a second, because I do have to do that other little weird stuff. And that's load in the STL file as just for visual purposes. And I just need to, again, use the alignment that I've just done. And I'll just kind of put this back on where I was before. Load from color map and do what's called a die to body. Do it one more time and load it from a fit, which is the pink ABC fit. And now I have both color maps. Oh, I forgot. I need to change the color of it as well. And so change the color. This time I'm actually going to change it to pink. And kind of to make a really short story out of this, too late, is I now actually have this has got nothing to do with CAD. I actually have my two STL files loaded as if they were perfectly aligned with each other to the best of their capabilities. It's going to be in webinar number 2 to actually align one to the other. But what we're showing right now is, because the datum structures were matching each other, we can align these very close and actually simulate putting them on top of each other. So I'm going to just turn these back off for a second, because I kind of want to show the next thing. And that's, if I just bring back my CAD model, let's kind of do the next thing a standard CheckMate user would do, which is show me whiskers. Show me what all this work you've done. When am I going to start to see the benefit of this? And that's if I create a whisker diagram, and I'll say create a point at nominal based on one group. And I'm going to go based on the black DEF group. And just show me, I want to use box and cross.
Now that was new, by the way, for CheckMate 2023 with the whiskers. You can have you'll notice the base of each whisker is customizable. You can have a square or a circle to help differentiate between components, I guess, eh?
Yeah. So then I'll just do that one more time, and I'll explain what I've done on the screen. I'm going to create a second whisker diagram based on the group, this time based on the pink part, and circle and cross based on the pink part, and I'll put them on top of each other. So obviously this is kind of, there's a lot going on the screen, and I think it's important that you've got both, you've aligned them both together, you're seeing how they are functionally going to work with each other based on their individual conditions. So what do you do next? Like, this isn't, what is the common thing to do next? And yes, we're going to be looking at a 2D thing, but if you zoom in on the whiskers, you can start to, if I hover over it in the bottom left corner there, you'll see I'm highlighting the pink part. So I can quickly see that all the pink part in this corner are leaning in, the black part are leaning out. So that's a good thing. And if I kind of just zoom and go around my part, you can start to see, whoa, I have a conflict in that, okay, most of them are green, but they're both leaning in the same direction. So I have a potential conflict here that if they're both leaning in the same direction, I mean, it depends how much the pink is leaning in versus how much the black is leaning in. And again, as you go around the part, you can kind of start to visualize where things are at. If I then just kind of turn off the whiskers for a second and I actually turn on my scan data, you can actually, again, go around the part and actually see, if I just kind of zoom out a bit, you can actually kind of sort of see the gap, but it really is hard to see. How do you see geometry that is kind of blocking each other, right? How do you get in there? So, whiskers are great. They've been around for, again, a long time, and they do use it, but they're great, but they don't really show well when you've got overlapping geometry. So if I kind of just turn these off again, I'm gonna go back to this level. This is where, again, just for visual purposes, they're perfectly aligned, and the question then just becomes, what do you do next? You've got them aligned. You've got some areas of concern. What's next? And there's a lot of things you can do from a GD&T point of view. There's the GTM browser, there's a root cause browser, and those are great when you're talking about component level verification. But there's a really cool new addition that I'm going to show now, which is the ability to walk through the mesh. And I've got two meshes that are aligned with each other. So this is a really nice way to actually tell, do these parts go together? And I'm going to just kind of say clip, and you can see that I already had one before. I've obviously worked with this file before, so it remembered the 23 value. But you can see it's just kind of doing a CAD cross section. So I hate to oversimplify it that way, but what you're essentially doing, though, you're not dealing from a CAD point of view. You're actually doing it from a functional mating and sectioning both parts at the same time. So if I then go along and say, I can choose where I want that section to be, I can walk along my part, very similar to what, things you've seen in the past. And you can do it in multiple axes, et cetera, et cetera. I find it really valuable. I'll just go back to 24 and hit apply and say capture edges. And when I kind of close that out, I'm going to hide the meshes. I'm left with kind of a 2D profile. And you can see there are some, again, taking this massive point cloud with all this great data in it and dumbing it down to what's going on with my part. And you can see,
you can really see. Wow,
yeah,
that's amazing.
You can kind of see that you've got some problems here, and you've got another major problem here of why it's not going down any further. Like, there's some functional issues here of why these parts aren't going to go together. And then you can just continue with that. So, you use the color maps at your component level to tell you if they're good or bad. You can use your whiskers to kind of hint in directions of where do I have overlapping problems. And then you use the clipping tool to say, well, let's take a deeper dive in these areas and see where the two parts kind of overlap. And I think it's a fabulous tool that makes a potential difficult scenario, quite easy to understand how it worked. So if I just do it one more time, I'll bring back the meshes and I'll just do that in the Z-axis as well. I think it's a really simple tool to demonstrate and take a deeper dive into a part. So I'll just kind of oops, I wanted to go Y-axis, not Z. So I'll just kind of play with it. So again, if I kind of go down and down and down, and we'll just say there, I can just say capture the edges again, and you can see the value in color coding this. So if I then just turn off my meshes again, maybe go down to a straight down view, you're kind of doing all this sectional stuff. So you can see you've got great gap between the two there. And if I just walk around, you can see that you start to get tight depending on where you took your section, obviously, where you've got functional fitting and where you don't. So it's kind of using all these strange, not strange, but using all these tools together of moving nominal files in, loading scan data in, processing them independently, aligning them independently, and then stacking them on top of each other to see if they're going to fit or where you have interference. So that's kind of the overview that I was hoping to get through today. Hopefully it's been insightful and people kind of understand what's going on, because you can see how the more you measure, the more nominals, the more profile tolerances, the more scan data. You really have to have a tool, and it's a tool that we use to solve problems. So I think it's a fantastic set of tools available to everyone to do this. So hopefully that's been insightful. And what we're going to do next is actually the kind of the next step in this process. We didn't want to ram too much in here, which is right now they're both nominally aligned, meaning make the pink as best as it can be to its ABC, make the black as it can be, the best it can be to its D and F and where they mate. And the next step in this is kind of that next step in SoftFit, which is actually merging these two together to create its own next part. So if something mated to these together, treating these as its own next group, yet we never measured them together. They could have been all done individually. So that's kind of the end of the presentation, Cecil, of what I wanted to go through and share what I've been using CheckMate and SoftFit for the last few weeks and months, actually, at a very high level, I think. Not just verifying parts or validating parts and which parts are good or bad, but using the data for multiple parts together to, using the data together to solve an assembly problem.
Well, thank you, Rob. I definitely appreciate that. Just a comment to everybody is that you saw him cutting cross sections through the mesh. That as well is going to be a new feature in CheckMate 2023. So come the new year, that will be available. That command will be available as well. Everybody, you can if you want. I think you can bring up the people list, and you can write. I think there's some dots to the right of your name or whatever. You can turn on your microphone if you want. I'm just going to have a quick little. We've got a few minutes here that we can ask questions, and I have a question for you, Rob. And it's not a checkmate question. But it's kind of, you guys at CAD Micro Solutions are specialize in selling scanners. I'm just kind of curious. Are you seeing any kind of, I'm trying to word this the right way. Are you seeing any patterns or anything like that as far as people buying scanners? And what I mean by that is are you seeing things coming from, like, is aerospace kind of exploding and getting into scanning, or automotive, is that a little bit slower or faster? Like, have you seen any patterns as far as who's buying scanners and what industry it's from?
Sure. I mean, automotive was one of the early adopters of scanners,
Hmm.
and I mean they're doing things in line now. So scanning validation was done 10, 15 years ago in the automotive world,
Oh,
but
okay.
but scanning in aerospace on production parts is still an evolving process, only because their standards and procedures were written around CMMs for so long. It's not a tolerance or a capability issue.
Uh, that was going to be my next question.
It was a practices and standards issue that
Right.
kind of like using 3D parts in jet engines. It takes it takes a while for those new things to be adopted, and especially when scanners are now being used to certify parts or validate parts or whatever you want to call it, that process just takes a lot longer in a lot of other industries. Where scanners have really taken off is as as scanners and the mesh sizing in scanners gets smaller. So you're
Right.
pushing 12 megapixels on a 50 by 50 millimeter area now. Um, as you get into small medical devices and things like that, things that you traditionally used gauges for or small scale CMMs to take minimal data sets, the smaller the geometry gets, that's where some what we call metrology grade scanners are really helping people understand their parts better.
Yeah, because there's some things that CMMs just can't do. Some things that some areas on parts that CMMs just, can't get at. Their probe, you can only get a so small of a probe diameter, to get into a tight area. So yeah,
Or
that's
if you,
cool.
I mean, there are things that CMMs can still do that scanners can't, like
Right.
deep geometry. But I think for the most part, unless it's a very tight tolerance part or deep geometry, I think scanners again for that 20 to 25 micron range now can do a great job.
Right. Okay. Well, thank you, Rob. Anybody else have any questions they'd like to throw out there? And
I do have a question. You probably have already answered this for us, but just in terms of this like fitting stuff, is there any plans or thoughts to go to where we can, this is great in an ideal situation where it's flat, but in our world where we have, you know, not flat components that become, they basically conform to each other when you bolt them together or something. Is there any plans to put like an FEA type element into this
So,
this
so that's
version or this type of fitting?
next kind of thing that they're working on is making this into how does a 3D fit come into play and doing 3D corrections,
Mm.
but reducing that back to visible data that you can action. So I appreciate the comment. I was just asked to do this part A. I don't have to sign any NDAs, but
Mm.
it helps just illustrate the points.
Okay, thanks.
So I hope that kind of answered the question.
So it's sort of it can be done, I guess, or it is being done to some degree
there's
already.
no
So
there's no limits to it. It's just the visualization tools are kind of now there that maybe weren't in the past. But mathematically for fitting, there's no issues three-dimensionally, whether
Hey,
that
Rob.
be scaling or anything. Yeah, go ahead.
Yeah, this is Jim. Um, I'm a little curious about the alignment process, just kind of an overview of that. So you started with two CAD models, which
Yep.
may or may not be in the same reference frame. And then you have two sets of scan data. Again, they start out wherever they start out. So in the process, it looked like you did two alignments. You took the actual CAD models. Apparently, they were already lined up to each other. Is that true?
They so the CAD models were assembled in world coordinates.
Okay. All right. Fine. And which that should be a perfect assembly, correct?
Yeah, that should be a perfect nominal assembly.
if they were properly designed. Okay, well then it looks like you imported the color map data.
Yep.
Now, what was that from? Was
So
that from the?
so the scanner went out and scanned the part and created an STL file. So
Oh, okay.
the first
All
time
right.
the first time we load it in is just to produce a color map and understand the relationship of where it was scanned in space to where it is on the model. So it's
So, all
just
right. So
the
that data, I'm sorry to interrupt, but so that data, which was scanned out somewhere in the world, did you best fit that entire data set to the CAD model?
100% yes. So
Okay, I got
so
you.
let me just see how quickly I can go back to that point. And unhide the color map. Okay, so when I loaded the STL file at this point, this was just loaded in what we call as measured state. So
Okay,
this is truly a best fit, throw it on the part, tell me where I'm at
of all areas. I
of
mean,
all areas.
it tried to fit that scan data onto the CAD model everywhere it could, best it could.
That's
Right.
correct. That's correct.
All right.
I
All right.
hate to say it this way, but just like in Polyworks and just like in GOM-Inspect and just like in a lot, it's just a least squares, throw it onto the part and tell me where I'm roughly at over and no waiting, just throw it on the part.
Right. And did you have to give it? I'm from the Polyworks world first, but did you have to give it some indication of how to do this, or
No.
did CheckMate do this? This was in
Yes.
CheckMate, right? All right. Yeah, because Polyworks, you got to give it some guidance.
No, there was no guidance. The
Yeah.
only variables, Jim, is you have to put in a number of expected deviation. Meaning, do you think the part is going to be within 1 millimeter of where it should be, or 5 millimeters, or 50 millimeters?
Okay.
So it
It
can
tried,
tweak.
so it'll work on it to try to get it within that guideline.
That's right.
Saying.
But again,
Yeah.
it's just the first iteration to throw it onto the part.
Yeah.
Right?
Yeah.
And then what I
Exactly.
did, you were right. I did do a second alignment. And there was a lot of magic that happened there because of the work that CheckMate was doing in the background. Because I had a program on this part that defined A, B, and C, or in this case, it was PA, PB, and PC, because it was already defined in the program from the MBD. When I right clicked here and said create alignment fit, it actually went and said, okay, where are those features on the part? Create all the reporting in it and then create an alignment. And that's what
Right.
allows me to actually go back and forth on that part between the best fit state and the alignment state.
Right. So you took basically you were taking the STL data then and aligning it according to
The datums.
The datum.
Yeah,
Yep.
that's what I thought.
So
Yeah.
that simple little right click create alignment is what's doing that. It's
Yeah.
saying I recognize the datums and the alignment from the program or from the MBD, and I'll go create that alignment for you. And
If
now
if you didn't have MBD, it would do it from your program alignment.
that is correct. Yep.
Yeah.
100%.
Okay.
So I did that twice on the other part because I wanted to create a reference frame for A, B, and C and for D, E, and F.
Well, now D, E, and F was D, E, and F on the mating part.
So
Part.
on the black
same
part.
area as A, B, C, or
Yes.
was it a completely different area?
Oh no, great question. Oh, Jim, you're great questions. So if I go back to the black part and let me just hide some stuff here. Oh, I actually want it turned off, not turned on. Turn off the pink part. Okay. And I don't need to see whiskers either. Oops. There we go. So on the black part, Jim, to answer your question, A was the bottom of the part, B was this pin, and C was this back face. Okay?
Okay.
D, E, and F actually became the mating for, so D was here, E was this center bore, and F was using this clocking feature.
Okay.
So I did it twice so that you could show the color map and how the actual part moves relative to whatever datum structure you're looking at.
So
But in
D,
the
E, and
end,
F.
you had that bore and the slot, the tapered slot. In the end, both of them were lined up to that bore and tapered slot. Is that correct?
Yes.
Yeah.
For that area of the part, yes. The black part still had its own A, B, and C, but the two parts were aligned through plane, cylinder, and the slot.
Yeah. Right. Okay.
The D, E, and F of the black part was the A, B, and C, the pink part.
Yes.
But okay, but
Because that's where they mate.
The gray part right now, though, you're saying the original alignment was the pin, the backside,
Yeah.
the bottom.
Well, that was
what letters were on that? Was that ABC on that part?
That was ABC.
On that part. Okay. Now I'm with you. Just trying to get my letters correct.
Well, that's the problem, Jim. That's what this is all about, is that when you start dealing with multiple components of the same assembly, if you go and look at the print or the MBD, they all have their own A, B, and C,
Right.
which would all be different, right? So
Well,
when you have to be able to handle that in CheckMate, having multiple segments, all with A, B, and C datums, but they're all different features.
Right, and that automatically took care of the repeat issue with the P in front of it, right?
Yes, that's right.
Yeah.
Well, if the design was intelligent, well, I would think that ABC on one part is also the same features of the ABC on the mating part, but
no,
it's not the real world, though.
But that's not the real world, right? The real world is those drawings go out to the suppliers to make the parts, right? Yeah, in a perfect world, and maybe one day MBD at the assembly level will manage a lot of that. But today, that is the problem, that there are these mating pieces that we think of individually, but when they come together, they don't align that way.
Right, because they got different datums.
That's right.
Yeah, Jim. If you think about it, it's like think of a car, right? If you have the full assembly of the car, it's going to have its own datums, A, B, and C. Probably, the center of the car, the front bumper kind of thing. That's kind of where 000 is for a final assembly. But then if you take a component like the mirror, a rear view mirror or something, its A, B, and C is going to be completely different than the A, B, and C of the final assembly of the car that it attaches to, let's say.
Unless they did it a little bit smart and everything relates back to car zero or truck zero. I mean,
well, that's how it used to be, right? That's car body, right?
Yeah.
That's how we used to do before we got into GD&T.
Yeah, it still exists. When I was working for the truck interior manufacturer, plastic injection molded, all those parts, we had to keep them in truck body coordinates when we were inspecting them. And and the datums, well, they have a full of datums, but the master locator was truck body zero. So,
but Jim, these are
both a little different.
It is and it isn't, because these are both in global coordinates. They just happen to be zero near the part. So
it's not perfect.
Yes.
Well,
so
if you add another part to this assembly, it'll have its ABC. No, it's not going to match the ABC that, or the DEF here. It's going to be somewhere else.
Right. No, I follow that.
All right. Well, we're thank you for the question, Jim. We're 2 minutes over, Cecil.
Yep.
Thank you for
this video is going to be available to be downloaded, so you can watch it again or show it to any of your peers. Rob, if you have any final thoughts, go ahead.
Just thank you for the opportunity.
Oh, it was great having you. Thank you.
No,
Thank
If
you.
people could email in questions if they had some we didn't get a chance to answer.
Yep, you can email those to support at originintl.com. That's all one word. Support at originintl.com. If you if you have any questions, just make sure you put a good subject line so we know what it is, like webinar question or something like that. And like I said, coming in the new year, we're going to be doing this again for all of you. And except we're going to be making it. We're going to crank up the complication a notch and add more parts,
And
more
multiple
components.
assembly.
Yes.
And multiple samples to work on process.
Absolutely.
that's great. Thank you
Okay,
very much, guys.
so thanks everybody from joining. Thank you, Rob. We appreciate it. Thanks for your time, everybody. Have a great day.
Take care, guys. Bye.